Okay, thank you. Okay, let's begin our lecture number 3 of PDE. So we have finished our lecture 2 on the formation of the PDE. Okay, so in the formation of PDE, we have seen there are some symbolic representation we can use to define some, the partial derivatives. Like, for example, if we take z as a function of x comma y, then we take dabba z or dabba x equal to p. Every time if you indicate p, which is equal to dabba z or dabba x. So like q and r is second derivative of z, and the xy derivative will be s, and the y second derivative is t. Okay, so this is what we have analyzed last lecture as well. So from this equation, let me start my things. So you can see, so this is the notation we are using for the first order partial differential equation. So now our thing also starting from how to form the first order partial and the higher as well. So this contains three type of variable. You can see x, y, and these x and y only the independent variable, and z we are considering as the dependent variable of x comma y, because we are having the derivative of x and y now. So z we are taking already, you can see here, for the z we are taking as a derivative of x and function of x comma y is a z. It is a dependent variable. Also you can see this p, q, r, s, t are the each derivatives of the with respect to the independent variable as indicated above. So you can see dabba z or dabba x equal to p, q, r, s, t. So keep it in your mind, these things. Okay. So this is how we're gonna form our partial differential equations. Okay. So next one, to solve it, solution of the PDE. Okay. So in that sense, let's say this is let's say this is my function, first order functions. Okay, f x y z a comma b. So this is the solutions, because it has the arbitrary constant, or some we'll see what are the things. Okay, a comma b we are having as a arbitrary constants. So this is a solution of our PDE. So from this we have seen f x y z p comma q is our first order PDE. Why? The RST, I can't include here RST because P and Q only the first order, no. So dabba z over dabba x, dabba z over dabba y. So this is the only first order things. Okay. So with two dependent variable, this is an independent variable. These are derivative of function. If it is have the, this is our first order PDE. Then let's say this is one of the solutions. So if they given this as a solution, if we don't know what it is actually, how to form the equation from these solutions that we have seen in our elementary differential equation as well, because they give you one solution with the arbitrary constant a, b, c or anything. You just form the actual differential equations in it. Likewise, we're gonna form our PDE as well. Okay. So what is the technique we have used? We have analyzed in our last class. It is eliminating this arbitrary constant using the derivative with respect to the whatever things. Okay. So that's what we're gonna do here as well. So only thing is we're gonna partially differentiate. Okay. So let's say this is our solutions, okay, that I have given with two arbitrary constants. So if we eliminate this and this, we can have x, y, z, p, comma, q, anything. Okay. So if we eliminate these two with this trick, we can get our solution. So you can see I'm gonna derivate this solution with respect to x. So it will give you this one. Y. Let's say my f x y z a comma b is my solution. Okay, is equal to 0. So if I derivate with respect to x, what do you get? So da bar f over da bar x. Okay. First of all, I need to derivate this one. Then I also have z also no. So I also have to differentiate that one as well. So first of all, I have, let's say, da bar f over da bar z. Why there is no, if you derivate with respect to y with respect to x, it will be 0 no. So we are only considering the x here because we are, first of all, you are differentiating with respect to x. So da by 4 da by x plus da f by 4 da by z, then z also a function of x no. So again I need to take da by z over da by x, which is equal to 0. All the other things will be gone. So you can see, you can substitute this one as a p. Okay, that's what it's there. Okay, da by f over da by x plus p times, they are taking here. Okay, p times da by f over da by z, which is equal to 0. This is the derivative with respect to x. Here we don't have a or b, no. So this is one of the equations. Then they are differentiate with respect to y. Let's say da bar is the same thing. Okay, I don't need to explain it. Da bar for da bar y. Again, da bar z over da bar y. That's why they use q. Similarly, da bar over da bar z, which is equal to 0. Okay, so we have this equation with respect to x, with respect with the equation for with respect to y. Then solving this 1 and 2, let's say 1 and we have already taken 1 something else. So let's say this is 2, this is 3. So if you solve this equation, 2 equation, you can formulate our partial differential equation. So that is how we're gonna, from the solution to the partial differential equation, how we can form it. Okay, that's the idea of these sections. So I have explained these things, so I'm going faster to the next actual things. Okay. Okay. There here to forming this one, because in the ODE case we have just used the elimination of arbitrary constants, because their situations come only for arbitrary constant here. But we're gonna derive by two types. Okay, so one is derivate by eliminating the arbitrary constant. Okay, we'll see. This is what our first thing. So by eliminating the arbitrary constant, we're gonna form our PDE. Second method, if you are having the arbitrary functions, so eliminating arbitrary functions. So when we solve like ODE, if you solve this actual PDE, you may come across some solution has an arbitrary constant, some solution may have some arbitrary function itself. Okay, sorry, this is not a constant, this is a function. Okay, arbitrary constant is one of the case and arbitrary function is one of the case. So here also we're going to analyze how to eliminate the arbitrary constant and forming the PDE. Similarly, how to formulate the PDE by eliminating the arbitrary functions as well. Okay, so first of all, let's consider only the arbitrary constant for now. Okay, so this is our 2.2. It says eliminating the arbitrary constant. So let me see the explanation of that. Let's say this is my actual solution equation. Okay, here I have a comma b as the arbitrary constants. This is my equation number 2. So then the z be regarded as function of two variables. This is already taken now. That is equal to function of x comma y. We have taken. It is not a independent variable. It is a dependent variable of x comma y. Okay. Then differentiating this 2 with respect to x and y, what I told you earlier, partially in turn we get this one, da by for da by x plus p da by for da by z is equal to 0. Similarly, this one, these two are we can taking 3. Then these from these two equations, eliminating two constant a and b from like this equation 2 and 3, we shall obtain our last equation of this one. Okay, so we are coming from the upside down. So using the solution to, we are forming our equation that we have used to in our elementary differential equation. So don't worry, everything is same. Okay, so solution to the equation is our process here. So if you are doing this equation, you can see x, y, z, they are p and q there. So this kind of equation is the first order, as I told you. Okay, only we are having the first order equations. Then we continue. Okay, there's kind of a note here. Okay, extra note. What it says is, okay, you can take like a note. Okay, it says, in a similar manner, it can be shown that if there are more arbitrary constants than the number of independent variables, the above procedure elimination will give rise to the partial differential equation of higher order. For example, in this question, you can say f x, y, z, a comma b is equal to 0 now. So we have two arbitrary constant, two independent variable. So if you taking x, y, partial differential of x, partial differential of y, you can find the solution. Okay, this will give you a first order equation. Okay, surely it will give you a first order equation of f x y z comma p comma q. This is how the equation will look like. These are the only variable will in that equation. But let's say, for example, if you have a equation, let's say solution x, y, z, a, b, c, for example, is equal to 0. See, we have two independent variable, but three arbitrary constants. So in that case, you may have to take the second derivative, third derivative, something like that. No, so you may end up like, for example, you may for this question you may need to find the second derivation, second order differential equation. Okay, so if you have d or c, e or something, so that if you have more, that's what they say. If you have a more arbitrary constant than the independent variable. So the procedure to eliminate A, B, C, D, you have to eliminate A as well as B as well as C, D, E. No? So you have to again taking the derivative only, you can take out that. So that's what we call as when you are solving those kind of things, you may form as a higher orders. So you know higher orders things, no? How to find the orders? The highest derivative in that equation is the higher order. Like if it is second order, like that, you know. Okay. So this is what they say in as a note. Okay, you can keep it in your mind. So we can see that one also when it comes. Okay. Okay, I'll erase this part. Okay, I'll go. So let's do some examples and you will understand some extra. Okay. Okay, this is our third lecture starting now only. So let's begin to do some examples. Okay, so I don't know, I have put the examples in your note. Please can you, if not, please write down this example. Okay, so first example for the derivative of arbitrary constants, we have this equation. Let's say find a partial differential equation by eliminating a and b from the equation. This is the equation they have. So this is a solutions. See, they have a, b, and some x and y. So this is our solution equation. Okay, solution. From this, we're gonna form what is our actual partial differential equation. This is what they asked to find. Okay. Okay, let's do the steps one by one, and you also copy with me. Okay. So write nicely how you have to answer in the exam also. See, first of all, in the solution, you have to copy the equations, what they have given. So you can write z is equal to ax plus by plus a square b square. This is my, let's say, my first equation. So I'm continuing my equation. So that's why I put 5. You can put 1. Okay, this is our first equation. Then differentiating partially. See, this is you have to keep it in your mind, because we are also doing ED in PD in OD. You so when they are also, you have to use differentiate with respect to or something. That is okay, because ordinary you don't need to tell, like positive and negative, you don't need to care about the positive. But if it is negative, you have to tell, no, it is a negative. So likewise, this is partially. So you have to tell, I'm partially only differentiating. Okay. Otherwise, the other person don't understand. They say differentiating, but they didn't use full differentiation, they may put wrong. Okay, so you have to clearly tell differentiating partially, okay, with respect to x and y. So I'm writing x and y. You can write one by one, okay. Differentiating partially with respect to x, what do you get? So if I differentiate this side, I'll get da bar z over da bar. See, this side only exists this one, no? Or these are constant, these are constant, these are constant. So ax differentiate x, then we will get a only. Am I right? Check yourself, okay? Again, you can write differentiate with partially with respect to y. So your choice, okay? So if you differentiate with respect to y, da bar z over da bar y, say this one will be 0 because there's no y. Here y only, so b. So these are constant, so it will be 0. All the other terms will be 0. So you don't need to write. You can write da bar z over da bar y is equal to b. See, I'll erase this one. See, we got the idea. I mean, da bar z over da bar x a, da bar z over da bar is equal to y. So this is also we know P is equal to, no? P is equal to A. This one you can say Q is equal to B. So you don't need to, so we have eliminated already now. We have found the value for A and B. So if you substitute that, that is fine now. So no need to, that's all our equation. See, within 2 lines we got the answer. So let's see, okay. So now they say substituting these values a and b in our main equation, main solutions, okay, we have found the value how to substitute p is equal to a, q is equal to b, or you can use that one or this value, both are okay. Substituting these values of a and b in our equation number 1, we see that the arbitrary constant a and b are eliminated and we obtain, okay, what is our equation? That is equal to ax plus by plus a square plus b square, no? So just substitute. This is for x, you substitute x into da bar z da bar. Y into, for b, you can say this one. Here a square, so entire square. B square, whatever the b square, okay? Or you can also, you can write like this. That is equal to px plus qy plus b square plus q square. Am I right? Okay, you can use this notation or this one. Okay, so this is our actual partial differentiation. See, within 2 lines we get the answers. So there are situations like that. Okay, so this is a kind of situation where we have the same number of independent variable and same number of arbitrary. So you don't need to worry anything. Okay. So please write down the things and copy whatever. When I'm writing also, you also have your note down. Okay, so it will be easy. Okay, so let's do one. Okay, what if it is less arbitrary constant? Okay, less arbitrary constant than independent variable. Okay, let's say I have only one independent one constant, but for the PDE we should have more than 2. No, let's say 2. For example, my equation like this: x comma y comma z, only a is equal to 0. So this is very easy, no? One time derivation enough, no? Okay, I'll give you one example. You have to try. Okay, can you try the example that is equal to ax plus y? Can you find the equations? So 1 or 2 steps is enough. So can you send your answers? What is the equation maybe? Like PQR, you can use PQ, that notations for easy sending solutions. So can you send your solutions? Okay. Okay. Send the Z, entire solution. Z is equal to this like that. Don't send what is A only. Okay. Okay. So you got the idea, no? So nothing that big thing. Okay. So you can say we have daba zato daba. If you differentiate with respect to x, you will have p is equal to a, and with respect to q is equal to 1. That is also constant, no? But you don't need to put anything. Like you can put like, for example, for a you can put px plus y. But this is 1, no? So either you can substitute here q also. So sometimes px plus qy also fine, no? So it says if it is so, you may have a number of different PDEs. Okay. So can you write down the note what I am telling? Okay. Are you all writing? Okay, I'm gonna tell you. Okay, I'm not right. I'm gonna tell you. Okay. When the number of arbitrary constant the note, okay, when the number of arbitrary constant is less than when the number of arbitrary, I'll write shortly, you write correctly, okay, constants is less than the number of independent variable, then elimination of arbitrary constants gives more than one possible PDE of first order. So you can see what this is the explanation. This is a note for the equation that I have given you in the equation. Okay. So because we have z is equal to px plus y also, okay. So you have taken one as like that. But that q also one. No? So you can say px plus qy also. So there are possible ways. No, there are two. You can tell as a equation. So both are correct. Okay. Okay. This is one of the note. Okay, also we have seen, let's see one example for okay, this example we have the same number of arbitrary constant and same number of independent variable, that's 2 to 2. Okay, x comma y and a comma b. So in that situation we have used this way. Okay, so okay, you can write that note also. Okay, this is one of the note. Okay. Okay, write down the next note. Just write correctly. Okay, I'm just roughly written. You just write nicely. these are number of and all. Okay. Okay, next note for this example situation. Okay. So write nicely. Second one say when number of arbitrary constants is equal to number of independent variable, then the elimination. See, in this equation we have only one solution, so that's what we're gonna say. Then the elimination of arbitrary constants will give a unique, okay, a unique, that is a unique PDE of first order. Okay, so we have seen what happened if arbitrary constant less than the independent variable. Okay, so what if arbitrary constant equal to independent variable? Also we can see what if more than also. Okay, so you can see when the number of arbitrary constants is equal to number of independent variable, then the elimination of arbitrary constant will give a unique PDE of first order. Okay, so for this you can see that example, or I'll give one more example. Okay, so can you try this example for this one? Let's say for example AZ plus B equal to A squared X plus Y, where A comma B are arbitrary constant. Okay, can you try the and answer me? Okay, our meeting will finish within 10 minutes, so we can join again. Try this example. AZ plus B is equal to A squared X plus Y. And send me your answers to the chat. Okay. Why I'm not getting? Yeah, I got one answer as the others. It's a simple thing, no? It's nothing, isn't it? It has az plus b is equal to a squared x plus y. So our actual process is to take out the a and b. So here we have b, we have a and a. So how to get rid of this? How to eliminate this? So we can use our differentiate. Let's say first of all differentiate with respect partially with respect to x. So what do you get? So z is a function of x comma y now. So actually you have to differentiate with respect. There's a constant over there. So a, let's say da bar z over da bar x, and b is a constant. That is okay. So it's equal to here only we have x. So a square. All the other terms will be 0. So if you take a not equal to 0, so this is important, okay? Because if you wanted to divide it by this, you have to make sure it is not equal to 0. Otherwise, so if it is a is equal to 0, if you divide it by, let's say, a squared by a, this will be a squared by 0, no? Or 0 by 0, no? This is not, can't divide, no? There's a point. We can't divide 0 by 0. Or let's say I'm going to divide b by a. This is also, it's like b over 0. That is also not possible. It will give you an infinity number. So first of all, you have to mention I'm taking as a not equal to 0. Therefore, I'm going to take this one as a p. Okay, p is equal to a. Then what about b? So I need to do differentiate. Yeah. So I don't need to differentiate y, no? Okay, so I have p is equal to a. Okay, then wait a minute. Okay, what do you think? Daba's wait, what happened? Daba. Yes, I need to partial differentiate partially with respect to y. Okay, what you'll get a again daba z over daba y. There's no y here. Okay, equal to. Okay, I'll write again. Okay. So first of all, I got my p is equal to a. Okay. Then if you differentiate with respect to y, you get a da bar z over da bar y. B is equal to 0. A is okay. Only y is there. So 1. Okay. So I have for the a, I have p. No. This is like a q is equal to 1. So a is equal to p. No. So if you write pq is equal to 1 also, one of the differential equation. But it's a unique, no? There's no other way. You can write either da bar z over da bar x into da bar z over da bar y is equal to 1. Okay. This is my equation or this is my equation. Both are same. Not this is a unique equation of different, different notation. Okay. So this is my last answer. I don't need to do anything because in my equation I don't have a or b, no. So this is my PDE. Okay. So very simple, but you have to think a little bit. That's all. Every time you just take the differential partial with respect to y. That's all, no? With that, you have to, make the equations. Okay. All right. So hope you get the idea. So if others you don't get, please write down. Okay. Okay. Let me continue these notes first of all. Okay. I'm not gonna give you the solution anyway. Okay. Write down this exercise and try yourself. Okay. Eliminate. Write down this question. I hope you can see. Okay. I don't want to show you the answer. Okay. That's why I'm hiding. Can you try this example quick as possible? Okay. You have to go a little faster because this is our last lectures now. Eliminate the arbitrary constant from z is equal to this one to form a partial differential equation. Okay. So it's not that much time, but anyway, you try it. Okay. Okay, I'll keep these things also as a homework or later. If you get the time, we can see the answer. Okay. So just write down the questions and I need to go a little fast. After we finish our notes, we can try our answers. Okay. So just write down the question and leave a space in your note. Okay. This is one question. Okay. Second question, try this one. Second. Okay. Let's see the situation where we have, okay, I think our meeting gonna finish now. So I will, let's join again, okay? So I'll write this one only. Ax plus by plus cxy. Please write down this question and this question, okay? Leave the space for this question and write this one. So when we finish, you join again quickly.